Aloha, Rich Halverson here. This is ITS128, and in this video I'm going to finish up Chapter 5. So let me get myself out of the way here. All right, so uh, the last video ended with Section 5.4, so let's start with Section 5.5, and in this we're talking about the if expression for branching. And we've learned about equal sign, not equal sign. We've learned about less than or greater than. But what we and now we're going to learn about using logical operators and, or, and not. And so you've seen these before, but um, basically you can have like some expression that evaluates to true or false, and something else that evaluates to true or false. And if it's an and operator, then both of them need to be true before the whole thing is true. So this is what the truth table looks like. If either one of them is false, then the output, then the and of that is false. For or, only one of them has to be true. Either this is true or that's true. For and, it's either this is true and this is true. You see. So and then there's this unary operator. It's kind of like a minus sign in regular arithmetic. It simply does the not operation. If it's true, not, that is false. So pretty easy. All right, so this is pretty straightforward. And so, of course, you can use these and or logical operators to, combine them with the less than, greater than, equality operators, and to make complex expressions to use in your if statements. So, okay, so a Boolean variable, can only take on the value true or false. An integer variable can take on any number that doesn't have a decimal point. It's an integer. A floating point number can be anything including a decimal point. A Boolean is just true or false. And so the expression here is a Boolean expression because it evaluates to either true or false. All right, so here you can go through and see and make sure you understand how to put these expressions together using logical operators. For example, days logged is greater than 30 and less than 90. So greater than 30 and less than 90. I guess we put an and here. Okay. Max cars is greater than 0 and less than 100. Yeah, that's so and. Num stores is between 10 and 20 inclusive, so it's greater than or equal to 10. These are all and? Oh, here's an either. Okay, so that'd be either. That'd be an or. All right, so make sure you understand how to do these. Let's see. Okay, so again, we will be using we use if, elif, else type statements to figure out, to detect ranges. And when we have the use of ands and ors, we can sort of combine more distinct ranges that would evaluate to the same set of statements, basically. So here in this If the user channel number is greater than or equal to 2 and less than 499, in other words, if it's between 2 and 499, then it's S. Otherwise, if it's greater than 1002 and less than 1499, it's H. In all the other cases, it's going to be E. Okay, so anyway, so 500, 555 is going to be E. Whereas 444 is going to be equal to S. And 1212, which is in between this and this, is going to be equal to H. So it's just another way of doing ranges when you can use these ands and ors. And of course, you can always use. Them. So here's an example of. We have been taking advantage of these implicit detection of either the lower part, the lower range or the upper range, by using these if, elif, else statements. You can also do it this way, where we don't take advantage of defining ranges implicitly, but of course the advantage of this way is there can be gaps. If we are explicitly defining ranges, then there can be gaps. Whereas when we're implicitly defining ranges, there usually are not gaps. It's difficult gaps. So let's do one of these. Looks like I did one of these here earlier. Let's do the one on this side. Okay, 5.5. Okay, so modify the given if statements. So 30% tax bracket is output if pay input is in this range. So modify it. So the 30% tax bracket is input this range. So if it's greater than or equal to 3,700, and less than or equal. So this should be and. That's all. Let's do another one. Let's just do another one here. Valid zip codes are in the range of 10,000 to 99950. Write a statement that outputs invalid if the zip code is not in that range. So it's going to be treated as an integer. This isn't right because there actually are zip codes that start with 0, but we aren't counting those here. So if zip code is less than 10,000 or zip code is greater than 99950, then print invalid input. Oh, otherwise print valid input. All right. Else print valid input. Okay, got that one. All right, so okay, good. You can do the rest of them. Very good. What's next? Let's detecting ranges. Okay, so now we're doing gaps, and now we really need to um, use these. Now this and or business can really come in handy. But let's see. Okay, so here's an example of you give discounts to anyone 12 or under, or anyone 65 or older, but in the middle gap, you don't give them any discount, I guess. Okay, so so let's do this one. You read in the user age, and if it's less than 12, then it's something. Um, if it is greater than 65, then it's something. Otherwise, it's something. So we just read in 67. It looks like that's going to be it's greater than 65. So the ticket price is going to be 12. So first that executes. It's nothing. Then it looks at that one, and that's true. So then it prints that out, and it sets that equal to that, and then it also prints that out. Oh, I better finish so I get the point. Another one, 19. It's not that, it's not that, it's that. So it's 14. There we go. All right. So this tests your understanding of that. All right, let's do a challenge. Yeah, these are nice. Oh, wait, have we? Oh, that's right. We did in a previous section. This is. We understand we can do this too. Oh, I didn't mean to do that. But this having these expressions where the variable's in the middle and then you have the range, surrounding it. Anyway, so let's do this one. Enter the output of the branch expressions. Okay, so let's start this out. X is equal to 6. If it's less than 8, it is less than 8. It is greater than 3. So this is true, and this is true. Therefore, we print A. Great. Let's do the last one. X is equal to 4. So we're going to do, oh, that's how you do a not. I was doing an exclamation point for a not earlier. Okay, so we're going to say if X is greater than 2 or X is less than 6, okay, then print A. Okay, so so first let's see what that is. Is X greater than 2? Yes, it is. That's true. So that means this whole thing is true. We don't even have to look at the other one because it's an or there. So we know this whole thing is true, but we want not. Okay, so because X is greater than 2, it is greater than 2. So that means this thing is true, but if we take the not of it, then it's not true. So this here is false. That's false. So we do this one. Let's take a look at this. This is true, and this is true. X is greater than 2, and X is less than 9. So we print B. So we're going to print B, and then we're going to print C. Okay, let's see if this is correct. It is. Okay. Let's do this one here. Integer apple count is read from input representing the number of apples. Output unsuitable if it's less than 10, it's more than 15. Okay, so notice, English is a funny language. One might normally just say if the number of apples is less than 10, but that's not really correct English because you can count the apples. So if you can count them, you should use fewer, the word fewer. If it's like, 10 point, if you could have 10.5 apples, if something like that's possible, then it'd be a better English to use the word less instead of fewer. But anyway, this is correct English, very good. If the number of apples is fewer than 10 or greater than 15, then it's unsuitable. Okay, that's all we do is just, okay, so if apple count is less than 10 or apple count is greater than 15. If that's true, then output unsuitable shipment. I think that's all I got to do. See if this is right. Yes, very good. Okay, let's do the last one. Full box if it's greater than or equal to 50 and less than 75. Jumbo box if it's equal to 25 or less than 155. Select another amount otherwise. Okay, so we want if a selection is between if a selection is defined by this range, so I'm going to do if requested napkins is less than or equal to 50, and I can do this thing like this. Okay, so 50 is requested napkins is greater than or equal to 50, and this three-way business is kind of confusing for my brain because I never I never did this in my earlier programming days. So if it's less than or equal to, if it's greater than or equal to 50, and requested napkins is less than 75, greater than or equal to 50, less than 75, then we print full box. LF requested napkins is greater than or equal to 125, and requested napkins is less than 155. If that's true, then print jumbo box. Otherwise, print select another amount. All right. Let's see. Less than. Okay, I'm gonna see if this is right. All right. Very good. Okay, these are not that difficult. Okay, detecting multiple features with branches. Okay, so sometimes we're looking at distinct different things, and it might look like one of these nice cascading if LF would be appropriate, but really it's a little bit more complicated than that. Let's see where we are, by the way. 5.7. I think, oh, we have to go up to 8, and then 9 and 10 are the things. Okay, so we're in 5.7. What time is it? 1:10. I got about another 20 minutes. All right, so you can go through this. Here, this is what are we detecting? Just a bunch of things. Okay, if your user age is less than 16, then it prints that out. If you see, these are distinct, different if statements. They're all independent. So, a user can be if a user is um, less than 16, it's this. But if you're greater than 15, it's going to say you're old enough to drive. If you're greater than 17, it's going to say you're old enough to vote. If it's greater than 24, it'll say car rental companies will rent to you. And if it's greater than 34, it'll say you can run for president. So if we run this thing, okay, so user age is 26. So it's not going to do, so this one's going to be false, but this is going to be true, and this is going to be true, and this is going to be true. So it's going to print out this, this, and this, but it won't print this one out. Okay, so you can run through this. Let's see, so pretty clever. All right. So this makes sure you understand the concepts here. So these are independent if statements. So you gotta kind of remember that. This is not independent. In this case, either this is going to execute, or this is going to execute, or this is going to execute, but not. That's all. In this case, both of these could possibly execute. So you just have to keep that in mind. All right, so let's do this one. Type the output, number of items is equal to 6. Okay, is it greater than 2? Yes, it is greater than 2, so I'm going to get this out of the way. That's it. Then it prints R. So it's only going to do this one, or this one, and it's going to do the first one it finds. Okay, the first one that hits. See, number of items is 6. This is true, and this is true, but it never gets to here, so it's never going to print E. I mean, not when num is 6. So anyway, that's the point here. Let's do the last one. Okay, so it's going to do it now. In this time, it's going to look at each one of them independently. Is num items greater than 2? Yes, so do A. Is num items greater than 8? No, it's not. Is num items equal to 4? Oh, yes, it is, so do H. And then do P. All right, do the rest of them. Okay, so you can also have nested if then else. So this can kind of be an alternative to having to using logical operators and just having a single level set of ifs. So you see, this is user choice equals 1, do this, and you could have if user choice equals 2 and num items equal less than 0, then do this one. Elif user choice equals 2 and num items is greater than or equal to 0. If that's the case, then do this one, and then otherwise do this one. See, so you can sometimes make things easier from a different depending on your perspective, where you nest the if statements. Where this if statement only executes if user choice is equal to 2. So something to look at. Okay, so what are we supposed to do here? Detecting multiple features with branches. Okay, so write multiple if statements. Okay. Well, sure. If car year is greater than 1951, then do something, print, I'm just going to do this. Oh no, it's separate if statements. If car year is less than 1963, then print something, and I'm going to fill that in a moment. If car year is greater than 2001, then print something. And if it's this one, I'm going to just copy this, do that just like this. Copy. Paste. And then the next one is 63. I'm going to copy that. And the last one is this. All right, let's see if this works. All right, very good. Okay, you can do the rest of them. All right, what's next? Oh, comparing data types and common errors. Okay, so this just gives you some nice tips here. You know, when you're comparing floating point numbers, it's not a good idea to use the equal sign to do equal. It's better to do greater than or less than, because when you convert from base 10 to base 2, you know, we like thinking in base 10, and the computer likes to think in base 2, so it converts. There can be some loss. You know, there can be some number that can be expressed exactly with a finite number of decimal digits to the right of the decimal point in base 10, but when you try to represent the same number in base 2, it ends up being a repeating integer. Okay, so there's lots of cases like that, and so that's why they suggest that you, if you're comparing floating point numbers, don't test for equality. You know, you got to make sure if you're testing something that looks like an integer, but it's actually a string, you know, you got to do that conversion and all that kind of stuff. So that's just kind of what this, you know, that's what this chapter talks about. Okay, let's just try one of these. I'm supposed to fix this. Oh, okay. Is that all? Yeah, all right. Not a big deal. Okay, so okay, let's do some labs here. All right, so it's good. We've got 10, 15 minutes or so. Okay, so let's start to do the first lab here. And it is 5.9. We're supposed to write code that reads in 3 integers and outputs the largest value. Whatever. Oh, it prints it out like that. Okay, so first let's read them in. I'm going to say val v1 equals int input. Okay, and then we have b2, b3, b3, and so I'm going to say now there's just a ton of different ways that we can do this, but and you're going to see problems that are just like this throughout this textbook in various forms. But here we're just figuring out we look at 3 numbers and we try to we return what the largest number is. So I'm going to start up. So I'm going to have this variable called largest, and that's going to equal to v1 just to start out with, okay? And then I'm going to say if v2 is greater than v1, if that's true, then I have a new largest. v2 is the largest, equals v2. Otherwise, I don't do anything. No. I want to put largest here, because v1 is the largest. Okay, so I start out with largest is equal to v1, because that's all I've looked at. Then I'm going to say, is v2 greater than largest? If it is, if it's true, then I'm going to have a new largest. Otherwise, I'm just going to leave largest right where it is. And now I'm going to test v3. If v3 is greater than largest, then set largest equal to v3. Otherwise, enter. Just let it be. And so now I have my largest. It's going to be in there. When you go through this logic, largest is going to be the biggest one. If some of them are equal, it's okay. It's going to just keep. It doesn't matter if they're equal. So, so let's just print that out now, just like this. Max. Let's see. Print. Print f max of, do these brackety things, and I'm going to do the first one is going to be v1 comma space v2 in there, comma space v3 end bracket, still inside the quote there, is largest. Boom. And then I close the quote. Okay, so if we run this and I enter in 1, 2, 3, let's run it again. Um, 2, 3, 1. Yeah, okay. Anyway, so that looks right. You can click. You can submit for grading and see if you get other points. All right, let's.